Alright, so we left the previous video where I have a problem with my model assumptions because it doesn't appear that my residuals are following a normal distribution. Alright, so how do we address this? And so we're going to need some transformations. Now, most importantly, I think that these transformations are going to be on the y. Okay, so you have a choice. You can transform x or you can transform y. And really, when you're going to transform x, what you want to be looking at are these plots of the residuals against each of the x values. And if you see some sort of, curve relationship, you might consider some sort of transformation on, one of the x values, okay? But when you see a problem with your distribution, you're going to start thinking about transformations for y. Now, you want to consider transformations on x before you consider transformations on y. Do I have any, big problems here, with the, I don't really see it, you could maybe make an argument that there's, maybe a curve relationship with the number of children, sure. Or there's something going on here in this BMI plot. We have a lot of residuals that are close to 0 and then some that are very high. We don't really want to see that. We want to see a random scattering around 0. So a transformation of BMI might be appropriate. Also for age, we have some high values for age and then not, the corresponding low values of the residual. You could maybe consider some transformations on, these x values. You can play around with it and kind of, see what helps and what doesn't help. But I think that we're going to get the most bang for our buck here by doing transformations on the y. So I'm gonna go ahead and do that here. Now, I have these heavy tails, which suggest that a transformation such as, I could start with the log or the ln transformation. And then if that doesn't work, I might consider a stronger transformation, but let's see how that does first. So let me do a new data or a new spreadsheet and call this data with transformations. All right, and I'm going to click my data. All right, I'm going to copy this, Control C, and then Control V. Okay. Since I'm using Excel to come up with my least squares estimators, I don't need this ones here. So I'm going to use this spot for my transformation. So I'm going to call this first one the ln of y equals, so I typed in equal sign here, and I'm going to type in ln, open parentheses, and then that y, and press enter, okay, and double click, fill it all in, okay. So now I have my transformed y. Go up top here to insert or data analysis, regression. Okay, if you have anything in there from before, delete it. For y, all right, so I'm going to highlight the ln of y. Okay, for the x data, so like I said, you could play around with maybe transforming some of these, but right now I'm going to keep them, and then Shift Control down to highlight them all. Okay, I have labels. Okay, output range. I want to call this, instead of with interactions, let's call this with log or ln transformation. Okay, and press OK. I like to move it to the end here. So let's move this around. Okay, so it's the last one. Okay, so this is what Excel gave me. So, sometimes it's nice to just double check that you didn't create any additional problems for yourself, because sometimes when you do a transformation, it kind of messes things up. So especially, these plots with the categorical variable are kind of harder to look at, but especially these plots with the quantitative variables, it looks like actually that might have helped for our BMI residual plot, but we're still seeing some high residuals We're still seeing some high residuals and not the corresponding low residuals. Let's go ahead and actually, I'm going to take this spreadsheet and I'm going to right click it and press move or copy. And I'm going to press create a copy. And I'm going to move it to the end. So press OK. And that's going to create a new residual. So it's exactly the same as this other residual spreadsheet. But I'm going to take these residuals here from this new model I just created. Shift Control Copy, or Shift Control down, then press Control C. And go to your new and press Control V. Some things will automatically update, but it's not all automatically updated. So the sorted residuals, it will automatically sort again. The semi-studentized residuals, I need to grab that new standard error. So let me delete what I have there. And so I want to take the sorted residual and I want to divide it by, go up, this standard error here. Okay, lock in B7. So use your $ and then press enter. Okay, and then get your cursor on that cell and double click and it'll fill it all in for you. Okay, let me delete what I've drawn. Okay, so let's look at all of the plots again. Now these plots, they do automatically update when you put in those new residuals. So this is the box plot and this is the histogram, and then this is my normal probability plot. Okay, so we're seeing we still have these we have a large tail. Now that definitely did help, but I have a large positive skew now. Okay, and the normal probability plot looks a lot better, but I'm definitely still seeing that divergence once I get up here. So that large right skew is still there. So if the LN transformation wasn't strong enough, then another transformation that I can do is, let me go back to my data with transformations, is the 1 over y transformation. So let's insert a new column here, and let's call this 1 over y. This is a stronger transformation than the LN transformation. So I'll type in equals 1 divided by y. Okay, and then I'll double click to fill that all in. Okay, and then, yeah, so let's do data analysis, press regression, okay, delete anything you have in there. Okay, so for y range, we want 1 over y, shift control down. For x range, let's go back up, highlight all of my x's, and then press shift control down to highlight it all. And I'm going to, instead of LN transformation, this transformation is called the inverse transformation. Looks okay, press OK. And let's move this to the back. I don't know why it didn't call it what I want it to call it, but let's call it multiple linear regression with inverse transformation. It's too long. That's why I didn't do it. With inverse transform. How about that? Okay. So this is the output that Excel gave me automatically. So let's look at some of these plots. Okay. So BMI plot's looking a lot better. It's not. Yeah, there's something interesting going on here. But let's, most importantly right now, what we're trying to correct is this large tail. So let us copy this one again. So let's move it, create a copy, move it to the end, and then go OK. And it's going to create another residual one. Let me delete some of my drawings here. And I want to replace these residuals with these new residuals from this new output with the inverse transformation. So shift control down to highlight them all, press control C to copy, and then move them back over here, control V. Okay, and then so it sorts it automatically, but it doesn't grab the standard error automatically, so I have to delete that. For the semi-studentized, I need to go over here and grab that standard error, which is right here. And then lock in B7. Okay, and then press enter. Get your cursor on that box, double click, fills it all in. All right, and let's see what we have. Wow, look at that. This box plot is looking much more symmetric. This histogram is looking a lot better, and this normal probability plot is definitely looking a lot better, right? We want it to go slope of 1, right? Slope of 1 through the origin, right? And yeah, definitely still a little divergence, but I'm much happier with this. So at this point, you know, I would be comfortable going ahead and moving forward to interpret some of these, you know, results that we have here. So we have, you know, all these different tests, the test for the significance of the model, the confidence intervals for these, you know, parameters here. I you know, at this point, I feel like our assumptions are close enough that we can start making interpretations based off of these guys. Now, one thing I want to point out is the way you interpret your beta when you've done a transformation, it's a lot more tricky. And we're going to talk about that in the next video.